Hello everybody, welcome to the video. Today we're going to be going over how to factor integers using a factor tree. And so before we go over specifically that, I wanted to remind you about some divisibility rules for integers. So basically these are all the divisibility rules between 2 and 10, not including 7. 7 has kind of a weird divisibility rule, but it's going to be useful to make a note of these divisibility rules right here as you guys do your factor tree. Particularly the one for 3 and 9, that's the one that a lot of people forget about, where you have to add up the sum of the digits. So we'll see an example of that, but these are all the divisibility rules between 2 and 10, except for 7, okay? Also wanted to talk about this notion of prime numbers. So remember prime numbers are only divisible by 1 and itself. So these are the first few primes right here. So 2 is a prime because it can only be written as 2 times 1. 3 can only be written as 3 times 1, and so on and so forth. Positive integers that aren't prime, so aren't one of these numbers, 0 or 1. So if it's not in this list right here, then they're called composite. So the first composite number would be 4, because 4 would be 2 times 2, okay? And any one of those composite numbers can be written as the product or the multiplication of primes, okay? So with that said, let's go over a few examples of writing the prime power factorization of some numbers. Starting with this one, 51. So as you guys do these examples, start with the first prime number, 2. Is this number divisible by 2? No, because it's not even. Is this number divisible by 3? The answer is yes, because if you add the digits, 5 plus 1, you get 6. And that number is divisible by 3. So we can rewrite 51 as 3, and if you divide 51 by 3, you get 17, okay? Now both 3 and 17 are prime, so what we can actually do is circle those, and we can stop here, okay? So the prime power factorization of 51 would just simply be 3 times 17, okay? Those are the primes that make up 51, so we can box our answer, and that will be it, okay? All right, everyone, so for our last example, let's do one that's a little bit larger, 200, okay? Now, there's a bunch of ways to do this number, 200, because there's a lot of different numbers that go into 200, but we'll start by thinking of 200 as 10 times 20, okay? So it's also, 2 times 100, it's also 50 times 4, but, let's just do 10 and 20 right here, and neither of these numbers are prime, so we can't circle any of these right now. So let's move on with 10. We have to write that as the product of primes. So we can rewrite 10 as 2 times 5, and both of those are primes. So what we can actually do is circle those, and we can stop there for that section of the factor tree, okay? So let's move on to 20 right here. And we know that 20 is going to be 2 times 10, and of those two numbers, 2 and 10, 2 is the only one that's prime. So we can circle that one and then move on to 10. We already know that 10 is 2 times 5, so we can break that down like this. And since 2 and 5 are both prime, we can circle those, okay? So it looks like here, if we have stopped, we have all of our primes right here, 2, 5, 2, 2, 5. And what we can actually do is rewrite 200 as 2 times 2 times 2 times 5 times 5, okay? And there's actually an easier way to write this because as you can see here, there's 3 2's written in red, there's 2 5's written in green. So we can rewrite this as 2 to the third power times 5 to the second power, okay? So that is going to be your solution. 200 is equal to 2 to the third times 5 squared. That's the prime power factorization of 200.